Hey guys, I just wanted to hop on and make a little video for the law of sines because I know it's a little bit confusing. So I just wanted to go through the slides that they gave you on Edgenuity and see if I can explain it for you a little bit. So law of sines is nice because it allows us to solve for triangles when we don't have a right triangle, right? Up until this point, we've been able to solve for triangles as long as we knew it was a right triangle or have more information about it. So now, in any generic triangle, ABC, we can solve for all of the sides and angles using our law of sines. So things to note about the triangle. Little a is always opposite angle A. Little b is always opposite angle B, and so on and so forth. And then the law of sines states that the sine of angle A over little a is equal to sine of B over little b is equal to sine of C over little c. And depending on which sides and angles you have, you only need to use two of these. You can also set it up this way or the reciprocal of each, right? So we could say A over sine A is equal to B over sine B is equal to C over sine C. So both work, just depends on what you have and what you know. So then we get into the ambiguous case. And this was a little bit confusing. So I definitely want to spend some time talking about this. So if you remember in geometry, we got to the chapter on congruent triangles, right? And there was different ways to prove that triangles were congruent. Side, 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 angle, side, angle, side, angle, 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 side. But you remember that angle, side, side didn't work. Do you remember why? Right? It spelled a bad word. We all got a good giggle out of that. But why mathematically did it not work? And the reason is in this top picture here, is because you could potentially get two cases. You could potentially get two different triangles. So if you look at this first one, right, when I swing this second side, whee, it never hits this bottom side down here. So in case number one, there is no triangle possible. But in case number two, if it's long enough, when it swings, it'll hit this side exactly once, and so one triangle is created. So case number two, one triangle is created. In case number three, when the second side is longer, then when it swings, whee, it actually hits in two different places. So I have two possible triangles that are created. So then it goes on to kind of summarize what they found. And essentially that's in this kind of piece down here. Essentially, when there's one triangle created, pen back, there's one triangle created, then it is a right triangle, right? It has to drop down and be the altitude there. So if this is little a, then sine of A is equal to little a over B. Or if you're solving for A, you would get A is equal to B sine A. Right? A is equal to B sine A. Or since A is H, then H is equal to B sine A. And then, right, that's one triangle. Obviously, if A is less than H, right, then it won't actually create a triangle, so no triangle is created. If A is too long, right, so that when it swings, it can't hit this side again, so then only one triangle is created. So then the only case I have where two triangles is created is when this A has to be less than side B, but when it swings, so that when it swings, it hits in two different places, right? A also has to be acute, otherwise I don't get an option. So let's look at an example, which I believe is in the review page. So triangle GHK. It tells me triangle G is 30 degrees, G is 3, K is 4. So the first thing I do is I kind of draw out a generic triangle. I'm going to say G, H, ooh, that was weird, G, H, K. G is then 30 degrees. Little g, which is opposite that side, is 3, and K is 4. So the first question is, how many triangles are there? So what I'm going to do is I'm first going to draw in kind of my height, if you will, and I'll call it H, because I think this is how they did it in the video. So if there was one right triangle, then it would be a right triangle, and H would be equal to the sine, right? Or I could set up my sine to solve for H. So if I said sine of 30 equals H over 4, H is equal to 4 sine 30. This is a nice one because 30 is just an angle on my unit circle. That's 1/2. So 4 times 1/2 is just 2. Right? So I'm going to erase that and I'm going to put a 2. So now I got to think, how many triangles do I have? Well, 3 is less than 4, but 3 is greater than 2. So if I think about that, if I think about this side HK, could I swing it and get another side over here that is also 3 units long before it reaches angle G? And the answer is yes. Yes, I could. There could be a 3 right there or a 3 right there. Right? So I have 2 possible triangles. So I'm going to solve both triangles. So I'm going to kind of draw halfy-halfy, right? And I am going to draw myself kind of my original one. All right, and that's going to be G, H, K, where this is 30 degrees. This is 4, this is 3. And then I have the other scenario where it creates almost an obtuse triangle, not almost, it creates an obtuse triangle. Like that. So then this is still 30 degrees, this is still G, this is still H, this is still K, but this is 3 and this is 4. So I've got 2 different triangles to draw, and hopefully you can kind of see them in my original picture as well. So I'm going to start by solving the one on the left-hand side. So I see that I've got the 30 and the 3 is opposite the 30. K is opposite the 4. So I can use my law of sines to set up this problem. So sine 30 degrees over 3 is equal to sine of K over 4. Cross multiply, solvey solvey. So 3 sine K is equal to 4 sine 30. Divide by 3. Sine K is equal to 4 sine 30 over 3. Sine 30 again is just 1/2. So sine of K equals 2/3. Take the sine inverse of both sides. right? So then I have that K is equal to the sine inverse of 2/3, which rounded, the measure of angle K is equal to 41.8 degrees. So then I can kind of add that to my picture. That is 41.8 degrees. And now if I'm looking at this triangle, the next easy thing to solve for would be angle H, because I know the three angles in a triangle add up to 180. So I can say that 30 degrees plus 41.8 degrees plus measure of angle H is equal to 180, or the measure of angle H is equal to 108.2. All right, so then I can kind of add that to my picture as well, 108.2 degrees. And then the last thing I need to solve for is little h, which is that side there. And now I can just use my law of sines again. Sine of 108.2 degrees over little h is equal to sine 30 over 3. You can use either of the other two sides, but I like using exact answers where possible. Little side note, that 108.2 is a rounded number, so I would highly recommend you use the exact number from your calculator. Oops. Stop. So then when I cross multiply here, I get h sine 30 equals 3 sine 108.2. And then I got to divide by sine 30 on both sides. So h is equal to 3 sine 108.2 degrees divided by sine 30 degrees. Use my handy dandy calculator. 3 sine 108.2 divided by sine 30, 5.7. And now I have solved this triangle. I found all three sides and all three angles based on that first piece of information. So now I go back, right, because I said that there was two possible triangles. Oops, my triangle kind of messed up there. There we go. There was two possible triangles in this scenario. So how do I get that other side? So if I look at my original picture, right, I said the 3 could be on this side or the 3 could be on this side, right, which really creates what I call an isosceles triangle. And we know that an isosceles triangle, if the sides are equal, then the two base angles are equal. And we already found what this one was, right? This angle was this angle in my original triangle. So this angle right here is 41.8 degrees, which means this angle is also 41.8. So if I want to find that angle there, it should be supplementary to the 41.8, which is going to be my angle K in this picture here. So the measure of angle K is equal to 180 minus 41.8 because it is supplementary to my original angle that I found for triangle 1. So that comes to 180 minus 41.8, or minus my original angle. Measure of angle K is 138.2 degrees. Now, the other way we could have gotten that was to remember that when we got to this point here on our first triangle, whenever we take the sine inverse of both sides, we really have two answers, right? So sine of k is equal to positive 2/3. As a side note, right, this little star I'm going to do right over here. So sine of k is equal to positive 2/3 in quadrant 1 and quadrant 2. So when I took the sine of both sides, sine inverse of both sides, I got that k was equal to 41.8, which means this angle over here is also 41.8. But I want the angle in quadrant 2, so I really want this angle right here, which I would get by doing 180 minus 41.8. So two different ways to do the same problem. Once you recognize that there's two possible triangles, you can either kind of look at it as an isosceles triangle in the original picture, or again, when you get to that point down there, think about sine is positive in quadrants 1 and 2. What should angle K be? But then once I get that 138.2, you can use your triangle sum theorem again to find angle H. Measure of angle H is equal to 180 minus 30 minus 138.2. Measure of angle H, oops, they shall be approximately's. It should have been an approximately 2. 180 minus that minus 30, 11.8 degrees. So this angle up here is 11.8 degrees. And now that I have that, I can use my law of sines. Sine of 11.8 degrees over little h, which is going to be that side there, is equal to sine 30 over 3. Do some cross multiplying. H sine 30 is equal to 3 sine 11.8. Divide both sides by sine 30. H is equal to 3 sine 11.8 degrees divided by sine 30 degrees. H is approximately 3 sine 11.8. I should have used an exact answer. I think either way you get 1.2. So, two possible triangles. Two possible triangles based on my given conditions. Once I know there's two possible triangles, I can solve for both. Make sure you draw your picture as accurately as you can so that you can kind of verify that that would make sense based on the stuff that you were given. Hope that's helpful. See you in office hours, if it is not. Bye, guys.